In this overview, we will be looking at different types of tests and how and where they can be employed. Perhaps it might be useful to think first as to what it is that causes software failure and what that means. Failures are caused by defects inside the system, and defects in turn are caused by errors building the system. Errors are with us all the time. To err is human, but it's a perfectly natural outcome for any sophisticated project that there are going to be issues with quality, issues with getting it 100% right 100% of the time. Whether it's a ridiculous deadline, the complexity of the system, inadequate preparation, be it training, be it testing, or be it indeed just the nature of new technology. We work in a profession which reinvents itself every 18 months. What does failure mean? Well, it might mean a loss of money or indeed time, a loss of a business reputation, or perhaps a complete project or partial project failure. But it can be even more serious than that. It can result in death or injury. Consider an air traffic control system and the implications of it going wrong. This is a very famous diagram, the resourcing triangle. Everybody wants a project which is high quality, inexpensive, reliable, and can be delivered tomorrow. Doesn't exist. If you squeeze any one of these three elements, you're going to impact on the other one. You want it done quickly, it's going to cost you money and quality. You want it done high quality, it's going to take money and time. You want it done cheap, well, it's going to hit the quality and it's almost certainly going to hit the timeline. So, make your choice. What is it that we need to look at? Our basics. Perhaps the first one is to say that we can't test everything. As we've already seen, projects are risky, and risk causes error. The greater the risk, the more testing implied. This gives us the basis perhaps of some kind of testing schedule, some mechanism for scheduling the more important tests ahead of the less important ones. Testing should look at a system prior to implementation, not afterwards. We test so we can find defects. Defects then subsequently have to be corrected. It's called bug fixing. Finally, it's a recognition of the fact that testing is just one aspect to help ensure the quality of the system. Taking our first point there, the fact that we can't test everything because ultimately our resourcing is finite. We've only got so much time, so many people, so much money. So what we've got to do is the important stuff up front and first. Now there's a very important principle called Pareto's principle, and Pareto's principle says that 80% of the system is using only 20% of the software available. What we have to do, of course, is find what that 20% is. And when we've established what the tests are and their relative importance, we can draw up a schedule that's going to allow us to know when we've successfully concluded the testing. It's one of the fundamentals of testing, the fundamental test process, the steps we go through regardless of our methodology. Perhaps most obviously, we need to plan. Having done our planning, we then need to understand what is required and design our tests accordingly. We have the design, then we need to implement the design, execute our tests, and once they've been executed, we need to look at the results. When we've got coverage, when we've investigated everything that should be investigated and are happy with the result, then we can close down the test plan. Testing does not happen in isolation. Testing is part of a development process. Development processes, software development processes, normally follow what's called a development methodology. The most obvious one would be the classic waterfall approach, sometimes called the SDLC, the Systems Development Lifecycle. What it relies on is a series of steps which are taken incrementally as we go through the project. Feasibility asks, why are we doing this? Analysis says, what are we doing? Design says, how are we going to do it? We build it, and then finally, of course, we must test it. So testing has a place inside the SDLC. a specific place in which it should occur. However, if we take those steps, we can see that we can prepare for testing even though we have not necessarily concluded the life cycle. So here is our life cycle again, ignoring feasibility, just focusing on analysis, which then turns into business design, which then becomes technical design, and then comes into writing of specific program specifications. Finally, that results in our code. When we've got our code, we can look back to our program design and start to see how we can unit test it, different phases of testing. And when it's successfully passed unit testing, we can start to think about things like modular testing, how the interfaces work. When we're pretty happy that the system is working from a technical point of view, we can start considering it from the point of view of the business and running through the kind of scenarios that the business would use. And then finally, we would give it to the users. We're looking for UAT, or user acceptance testing. So you can see here we've got a sort of a V shape as we consider, well, what are we doing in analysis? We're looking at our requirements and our objectives. We can start writing the acceptance plans. When we start designing it from the business point of view, high-level business design, we can start to see what our system test would look like, and so on with our technical test and program design. The SDLC, of course, is not the only methodology used. Increasingly these days, people are using an agile prototyping methodology. The process is more embedded and iterative inside the development life cycle. We also have the idea of business process re-engineering, where perhaps we're reusing existing software or integrating it into the business in a new way. And this too will result in a different testing paradigm. So, how do we get these tests? We have what are called specification-based testing, some also known as black box testing. Black box testing, we care about what goes into the box, we care about what comes out of the box, but we don't really care about how it does it. So that really equates to our system testing and UAT testing. Another more technical type of testing might be structure-based tests, which rely on white box testing. White box testing, we put the input in, but we're very interested in about how it generates the output. It's a technical kind of test, perhaps more typical of unit testing and modular testing. And our third type of testing is experience-based tests. Tests where we rely on business expertise and the expertise of the testing staff to try and find errors which have perhaps not been recorded in our structure or specification-based test. That concludes this screencast. Thank you very much for listening.